Hey guys, we're back with another chapter for class 6, and this time the name of the chapter is force. Okay, force. This chapter is very important chapter. You will be studying more and more about this topic, that is force, in higher classes. So please watch this video carefully, and if there is any question whatsoever, please contact me and ask me all those questions. Whatever question you have regarding this chapter, regarding whatever we talk about, please ask me. Okay? So we move on to the chapter, and again the name of the chapter is force. What is force? Force is basically your push and your pull action. Okay? So when you push something, okay, when you pull something, what do? You applying force. Okay? The pushing and the pulling action, that is your force. So now let's look at the definition. Definition of force is, a force is any interaction that, when unopposed, will change the motion of an object. Right? So when you push an object, it moves. When you pull an object, it moves. So what it does, force changes the motion of an object. So when there is an object that is not moving, and when the object is not moving, it is said to be in rest. Okay, we say that the object is in rest when it is not moving, and when you push it, it moves. So the object is in motion. Right? When you pull it, again the object is in motion. Now imagine a scenario where the object is already moving. For example, a ball. A ball is flying towards you. You grab it. What you do is you apply force and you stop that ball. And you put the ball to rest, that is not in motion. Okay, stop the motion of the ball. So force again does the same thing, it changes the motion. At first it was in motion and now it is at rest. First it was moving, now it is not. So again, changing the motion of an object. Okay, that is what you can do. You can either have an object moving, or you can have a moving object stop. So what does this definition really mean? What does it mean? The push or pull on an object with mass, okay? An object always has a mass, that causes it to change its velocity. Velocity is the speed. Okay? Velocity means speed at a particular direction. Okay? That is that. Now let's look at effects of force. What does force affect? Does force affect mass? No, it doesn't. When you apply force on an object, does the mass of the object change? No, it doesn't. The mass of the object doesn't change. But what changes? The speed of the object changes. Right? So you have an object which is at rest, you push it and it moves, so its speed changes. What it can do is, it can make a stationary body, that is a body at rest, a body that is not moving, that is an object which is not moving, move. And it can make a moving body stop. Right? Direction. It changes the direction of the movement of the object. Imagine there is an object just sitting there. You apply force from this direction, it moves that way. Right? So imagine it's moving that way and you apply the force and you pull it. So it comes back this way. So the direction of the movement of the body or an object changes because of force. And it changes the shape and size. This is a very easy thing to understand. You know clay, when you apply force, when you squeeze it really hard, the shape changes. Okay, when you press some objects very hard, the size changes, it becomes compact. Right? So force, what force does is, it changes shape and size. Again, remember, it does not change the mass, it changes the speed, it changes the direction, and it changes the shape and size of an object. Let's move on to types of force. There are two types of force. Okay, one is contact force and another one is non-contact force. By the name itself, you can understand that for contact force, the object, okay, and the source of the force has to be in touch. They have to be in contact. They need to touch each other. But for non-contact force, they did not touch each other. Okay, so let's look at the definition. It requires physical contact between the object and the person or thing applying force. Again, for contact force, they need to be in contact, they need to touch each other. But for non-contact force, it does not require any physical contact between the concerned objects. Okay? So let's look at different types of contact forces. Different types of contact forces are your normal force. It is a force exerted on an object that is in contact with another stable object. Okay? For example, a book on a table. Okay? So the book is applying force downwards, right, on the table, and the table is applying force upwards on the book. That's why the book is there. It's not falling down. Okay? It's not crushing the table. That is why it's there, the force being applied. Okay, that is your normal force. Next one is the frictional force. Now to understand frictional force, imagine a scenario where you have a box on the floor and you're trying to move that box. But the box is not moving. Why? Even though you're applying the force on the box for it to move, it is not moving because there is another force that is stopping, that is resisting the amount of force that you're applying on it. That resisting force is your friction. Okay? Applied force is basically when a person, that is when we apply a force on objects or things, that is your applied force. Okay? Next one is the spring force. You have played with the spring. When you compress the spring, okay, you feel there is a push coming from the spring, right? That push is the spring force. Okay, and the tension is basically, to understand this again, imagine a rope. So you take a rope, you hold it at the ends and you pull it. Okay, you pull that rope very hard and you feel that the rope is very tight. That tightness is the tension. Now let's move on to non-contact force. Okay, there are three types of non-contact force that you need to know about. The first one is the gravitational force. The gravitational force is the force that pulls an object downwards towards the ground. Okay, so if I leave this pen, let go of this pen, it falls, right? Why? Because it is being pulled towards the ground by the gravitational force. And electrostatic force is the force that attracts the charges and repels the charges. Like charges, like positive charges and negative charges, they repel each other. Like charges, that is, positive repels positive charge, negative repels negative charge. Okay, but different charges, unlike charges, that is, positive and negative, they attract each other. This force of attraction and repulsion is your electrostatic force for charges. And for magnetic force, similar kind of concept, but instead of charges, it's the poles. Okay, you have North Pole and South Pole. So now North Pole repels North Pole, South Pole repels South Pole. But when we have different poles, that is North Pole and South Pole, they attract each other. Again, this attraction of different poles, okay, and repulsion of same poles is your magnetic force. Next is weight. This is a very important topic that you need to understand. So if you have any questions regarding this, please contact me. Okay, so what is weight? Weight is basically the mass. Okay, every object has a mass, okay, and the gravitational force that is being applied on the mass. Okay, together, mass and the gravitational force that is being applied on the mass together. So to understand it simply, you have mass, okay. When the gravitational force is applied on the mass, we get your weight. Okay, so and again, that is how we calculate weight. That is all you need to remember. So let's look at the definition of weight. Weight of an object is the measure of the gravitational pull or gravitational force exerted on it. Okay, It is the product of mass m and acceleration due to gravity. We already discussed it. W is equal to m into g, right? Now acceleration due to gravity is written as g. Okay, it's a constant value, it doesn't change, and the value that we take it out here on earth, okay, and for calculation that we use it is 9.8 meter per second square. Okay, that is the value of the constant, that is acceleration due to gravity or small g. Now, friction. We talked about friction. Friction was the resisting force, right, that stops a body or doesn't let a body to move, right? So let's look at friction in detail. The definition: friction or the frictional force is the resistive force acting between two bodies that are in contact, right? So what it means is, again, like I discussed, you have the box, you're pushing the box, and the box is not moving. Why? Because the force out there is more, the resisting force is more, and the resisting force is always on the opposite direction of the force that you are applying. So if you were to look at it, imagine there is this box, okay, and you're applying your force this way. The box is not moving. Why? Because there is a resistive force which is being applied in that direction. This force is your friction. Okay, it moves. This force is always applied in the opposite direction of the force that you apply.
Now let's look at types of friction. There are two types of friction: static friction and kinetic friction. Static friction is the kind of friction that you face or come across when you're trying to move a body that is at rest. So like we discussed before, imagine there's a box on the ground and you're trying to move it, and the box is resisting. Okay, it's not trying to move, you're applying the force, box is not moving. So what is happening? There is resistive force, friction, that is acting on it. So the force, resistive force that acts on a stationary object, that is an object that is at rest, or static object, is your static friction. And when a body is moving and you come across friction, like for example a rolling ball, you let a ball roll on the ground and after some time it stops. Why does it stop? Because of the resistive force that is acting on the ball that makes it stop. Okay, this is your kinetic friction. Now there are two types of kinetic friction. One is sliding friction and the another one is rolling friction. Now like the name suggests, sliding friction is basically when a body is sliding on the floor. Okay, like a box you're trying to push and it's sliding on the floor, the resistive force that you feel during that motion, sliding motion, is a sliding friction. And when the ball, we talked about the ball, so when the ball rolls on the ground and the friction that it faces is your rolling friction. Now let's move on to effects of friction. So what does friction do? First thing is, it produces heat, it reduces speed, and it causes wear and tear of material. So let's look at it in a different way. How do we understand this? Take a hand, both your hands, and rub your palms together. Okay, put your hands together and just rub them. Due to friction, after some time your hands will get warmer. Okay, the heat is produced because of this friction, and we can use this in many things. Like for example, we can rub two sticks to generate fire. We can strike two rocks small stones to generate fire. Even the matchstick, on the matchbox, the fire burns due to friction. If you were to check the matchbox, if you just feel the matchbox, you'll feel that it has a lot of grooves and it is rough. And if a body is very rough, then it is going to have a lot of friction. So when you rub the matchstick on the box, which is very rough, it generates fire, okay, and which in turn generates heat. So friction produces heat. Second, it reduces speed. This we can understand again through the ball. You let a ball roll on the ground, after some time it comes to stop. This is due to the friction that it faces. Friction always acts on the opposite direction. Since it's acting on the opposite direction of the force that has been applied, it reduces the amount of force. So the speed decreases. And it causes wear and tear. This is again, you'll understand it easily because this happens to us in everyday life. You walk every day, you run. After some time, you'll see that your soles of your shoe, they become old. There are wear and tear in them. This is due to the friction, okay? And friction makes wear and tear happen in many objects, in tires, in materials. It comes in contact with other materials again and again. Friction is very, very important to us, okay? It makes this all type of motion possible. It helps us walk. Imagine there were no friction. We would just slip and fall. Most probably we'd just be sliding around, not walking around. And we would not be able to stand in one place, because if we try to stand on one place, we would just slip and move because there's no friction. Okay, friction gives us that grip. When we're trying to walk, it gives us that grip. And for us who are living out here in Kalimpong, which is a hilly area, mountainous area, most of the path is inclined, right? Imagine there were no friction. We would not be able to climb all that inclination. We'd be trying and we'd just be slipping down, down the slope. It helps in cars too. If there were no friction, the cars would not move. The friction, the grip of the tires would not work. And the brakes in the cars would not work. And if the brakes would not work, there would be a lot of accidents. And people would stop traveling in car. Mostly people would stop traveling. We might have to chain ourselves to the spot. Why? Because there's no friction, there's no grip, and we'd just be sliding and slipping everywhere. One of the very important advantages of friction that happens and we don't see much, but it's happening, is that asteroids burning in the atmosphere. Even as we speak, there might be places where asteroids are falling due to the friction. Due to this friction, the asteroids, they burn in the atmosphere. Okay? But if we didn't have friction, there would be big, huge fireballs raining down from the sky, and there would be a lot of disasters, and it would be very harmful for us human beings and other flora and fauna of the planet. And this one, the last one, we have already talked about. It helps in generation of heat. Not just our hands, but even the matchbox, rubbing of two sticks, and striking of stones, among other things. What are the disadvantages of friction? Most importantly, friction produces a lot of unnecessary heat. Okay, and this results in a lot of energy which goes as waste. Second one is force of friction acts in the opposite direction of the motion. So it decreases the speed of the objects. and to maintain the speed or to increase the speed, a lot of energy is used. Okay, so again, this also results in loss of energy, okay, or loss of speed or acceleration in moving objects. Next one, it causes forest fires due to a lot of friction between the branches. We talked about, right, previously, that we can generate fire by rubbing two sticks together. Similarly, imagine there is a dry place and there are trees, where the branches are touching each other, and due to some wind, some breeze, these branches move and they rub each other and the fire starts. Okay, and so many forest fires that happens is because of this, because of friction. And lastly, a lot of money goes into preventing friction. Okay, like I told you, like wear and tear happens in our shoes, not just in shoes, tires, and so many other things. And to make sure that this doesn't happen, expensive materials are used to prevent this from happening. Okay, we have to lubricate things. To lubricate things, the lubrications are expensive. Some of the lubrications that are used are very expensive. So a lot of money goes into preventing friction. So how can we decrease friction? We can decrease friction by making the surfaces smoother, because rough surfaces produce more friction and smooth surfaces reduce friction. Lubrication is another way to make a surface smooth. Lubricants like grease, oils can be used. Okay, you can make the objects more streamlined, like for example airplanes. Okay, for example, airplanes. If you look at the body of the airplanes, the way they are made, they are curved. Imagine they were boxes, then they would not be able to fly it. There would be a lot of friction in the atmosphere, and because of that, they would not be able to fly. Similarly, even the vehicles, the cars, if you look at the cars, they're rounded up. A lot of designing goes into the cars. And if you look at cars or fast cars, the designs are very, very streamlined, something that restricts friction. Next, you can reduce the force. Okay, when you reduce the force that is acting on the surface, then you reduce the friction. And lastly, you can reduce the surface area. Okay, and this is also related to the streamlined, making the object streamlined. When you make the objects streamlined, the surface area that the friction acts on, okay, the friction is acting on the surface area. When the surface area where the friction is acting decreases, then the total friction that is acting on it also decreases. If the surface area decreases, then the friction also decreases, and if the force decreases, then the friction also decreases. Now, how can you increase friction? Very simple. You can increase the friction by making the surfaces rough. If you look at the shoes, okay, the shoes has a lot of these grooves. What does these grooves, these designs, what they do is they increase friction. Similarly, if you were to look at the tires are not smooth. There are a lot of grooves. These grooves give us the grip. Okay, and the grip is nothing but the friction. And the other thing that you can do is you can increase the mass of object. Okay, when you increase the mass of the object, what happens is, in turn, the weight of the object increases, and weight is your mass and your gravitational force. So since the weight increases, the friction will also increase. And thank you, that's all for the chapter. And if you have got any question regarding this chapter, please do contact me. Thank you for watching the video.